We now write a function to represent the rabbit population t years after January 1, 2011, when the population of the rabbit is 24 on January 1, 2011. And we are also told that the number of rabbits tripled each year. So I'm going to use this population model, that is P of t, and this equals P naught n raised to the power of t by this uppercase T. Let me explain the terms in this model. This represents the population of rabbits after t years, and P naught represents the initial population of the rabbits. This is initial population, and the n represents whether it is tripling or doubling. Suppose if the population doubles, we say that n equal to 2. If the population triples, we say that n equal to 3. So basically, this n represents whether it doubles, triples, or each other. And then this t is the general t, which represents the time in years or in terms of units of time. And then this uppercase t, this represents how frequently the population doubles or triples. So it doubles here in this question. We see that it triples each year. So we say that t equals 1 here. And so let's write down the model now. I'm going to write down this as P of t, and this equals, we know that initial population is 24. That is on January 1, 2011, we consider it as an initial population. So we can write down 24 times, and we know that the population triples each other each year. So I'm going to put n as 3, and then raised to the power of t divided by it triples each year. So therefore, we already mentioned that capital T equal to 1. So I'm going to put this as 1. So we can simplify and rewrite in proper expression. That is, we say that P of t, and this equals 24 times 3 power t. So this is the function which represents the number of rabbits t years after January 1, 2011. Let's answer part B. Here we have to determine the number of rabbits in January 1, 2020. So we can use this model which we found in part A, that is P of t equals 24 times 3 raised to the power of t. And so to use this model, we have to determine t. So t represents the number of years after January 1, 2011. So if we look at the t, the starting year is 2011, and we have to determine the number of rabbits in 2020. So it's basically, we have to determine t, and this equals 2020 minus 2011, and this equals 9. So we found that t equals 9 years. So therefore, we have to determine p of 9. We plug in t equal to 9 into this population model, which gives p of 9, and this equals 24 times 3 raised to the power of 9. We plug this into the calculator, and we get 472,392. So this is the number of rabbits in January 1, 2020. Let's answer part C. So here we have to determine the percentage change per year. So we write down this percentage change in terms of formula, and this equals the change in population for 1 year, this divided by the original population times 100. So we can say that we can consider any 2 years to determine the change in population. So here I'm going to consider the population that is at the beginning and after 1 year, so which is represented by P of 0 and P of 1. So we can say that the change in population is P of 1, which represents the population after 1 year, and P of 0, which basically represents the initial population, and then divided by the original population, that is P of 0. And this multiplied by 100. So we put P of 1. P of 1 is 24 times 3 raised to the power of 1 if we use the population model, minus P of 0 is basically the initial population, that is 24, and this divided by, once again, it is 24 times 100. So it equals 24 times 3 is 72, minus 24 divided by 24, and this quantity multiplied by 100. So this gives 72 minus 24 equals 48 over 24 multiplied by 100. So this reduces to, we can cancel this 48 with 24 as 2 times. So it's basically 2 times 100 is 200%. So we say that the change in population is 200%, and it is 200% per year.